Personalised baseball bats, they make a great present and easier to produce than you think. Let me show you how. Swing batter 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 swing, and welcome to another episode of James Dean Designs. I have had this on my to-do list for a while and I've now finally got around obviously to making it as well as the tutorial. I'm going to give you the first piece of advice straight up front. Don't think about it as machining a bat or a cylinder. Simply think about it as machining a square block of wood and everything will be much easier. So let's dive in and I'll show you how I achieved this personalised bat. Now, I have one bat, one chance of getting this right, and I've also left the plastic coating on just for protection at the moment. This is just a cheap bat off Amazon. I will put some links in the description area so you can find them. The overall length is 32 inches, but we are just focusing on the section that we plan to cut, which is roughly this area here. Now, the first measurement we need to take for our work area is going to be the diameter of the bat itself. Now, this is coming in at 49 millimeters, so just under 2 inches in diameter. Now, we need to take the width of this, but obviously it tapers off this side and we have the curvature going on at this end. So I'm going to bring a piece of tape in as a reference and place this maybe just under an inch in from this end. I'm going to stick that there, and a similar thing on this side where it starts to taper off, maybe around here. Just put another piece of tape as a reference point for our work area. Now, if I bring the tape measure in, we are looking at just under 11 inches, 270 millimeters. So my work area is 49 millimeters by 270. Now, I'll jump over to the software and show you how to do this. You can do it on most CNC software, but obviously I use Carveco Maker, so that's what I'm going to quickly demonstrate now. So in Carveco Maker, the first thing we need to do is generate our work area. We'll click New Model, put in our measurements, 270 by 49, and leave the origin for the job or the start position in the center and resolution at full. We'll then click OK. One thing I'll quickly mention before we start is that on my machine, I will be machining this front to back as opposed to left to right. So in that scenario, you would need to do your work area the opposite way around. Rotate it 90 degrees and do all of the toolpaths this way. But for the purpose of demonstrating this, obviously I'm going to do it left to right because it's easier to view on screen. Now at this point, we need to generate two things. One is the text and the other is an outline border to help with the machining. So we'll start with the text first. I'm going to click the text tool, go to the middle of the canvas and start to type out my name. Now what we can see, obviously the text is way too big here, but the first thing I'll point out is use something like a very chunky text, something like Arial, bold, impact, black, that type of thing. You want a nice chunky text in order to achieve a good result. Now what I'm going to do at this size is adjust the sizing of the text using the scale and the width options to fit within the area we want. I will speed this up on camera because you don't need to see it all, but ultimately it's about getting it to fit within our work area. The text overlap in the top and bottom will actually leave the nice curvature of the bat in place and just make it look cleaner overall. So what I've simply done is stretch the text to go over the top and bottom, but stay within the width on the left and the right itself. Now the next thing we need to do is draw a border around this. So we're going to come to the rectangle tool. We're going to start at the full width, but just above the text itself. And then we're going to drag that all the way to the other side and finish on the full width and again just below the text on the bottom. We're going to click to create to make that permanent, and then we're going to use the arrow tool to select both of those together, the text and the rectangle, to create our toolpath. So we're going to head to the toolpath options. Now you could try and do this using an area clearance toolpath, but you will get better results treating it as a V-carve. So we're actually going to select the V-bit carving option in order to achieve this. Now we're going to leave the start depth as 0 because that is the top of the bat surface. In terms of the maximum depth, you don't want to go any deeper than halfway through your bat. In fact, I like to go less, so we're going to do this at 20 millimeters deep. Obviously my bat was 49 millimeters deep in diameter. Now in terms of carving this out, we'll be using two tools to do it. We're going to go round and do a roughing pass with a 1/8 bit to clear a lot of this dead material. Then we're going to finish up with a tapered bullnose bit. So we'll start by selecting the finishing tool first, or the carving tool, and I'm going to use a 1 millimeter tapered bullnose bit to achieve this. So I'll click select. and load that in. Now in terms of the feeds and the speeds, obviously this is just for demonstration purposes, so I'm not going to show you those on screen because it is all dependent on your particular machine and setup. Now we're going to come down to the roughing tool option, and I'm going to select a 1/8 bit or a 3.175mm bit, which is exactly the same, and load that in. Again, I'm not going to touch these settings themselves because it's just for a demo. You need to set these up relevant for your machine. Then we're going to come down to define the material thickness, and we'll put 49 in and click OK. We're going to give this a toolpath name of just James Dean for ease, and then click calculate now to get our toolpaths. And with all that done, we can right click and click simulate to give us an idea of what the outcome will be. Now, if I zoom in and rotate this around a bit, we can start to see what we are achieving. Now, when I said earlier on about putting the rectangle around the outside, obviously this is to show that we wanted to machine all this dead space here as opposed to actually machining out the middle of the text, and that gives us this 3D relief text that we are after. The final thing we just need to remember, obviously the bat is curved, so sort of this top and bottom edge are going to have a nice radius on in the shape of the bat. So with all the toolpaths generated, all we need to do is export them, move over to the machine and get this set up. And for those who use easel, it is exactly the same. Your text, a rectangle, the only difference is you need to make sure that the text sits on top of the rectangle, and then your output will look the same as it does on this right hand panel. So this is my monstrosity of a contraption to hold the bat in place, but in reality you would probably generate some sort of jig if you were doing these on a regular basis. I'll quickly run you through what I have done. So first we've clamped 2 scrap pieces of material to the side of the bat, and one thing to remember, when you're clamping square edges against rounded edges, it will have a tendency to lean them in or out. So what you would likely do in reality is put some sort of groove or V down the inside of the scrap wood in order to clamp it better. Or even what you could do is shape these so they taper back downwards, so as it clamps in it is pushing the bat down. That probably would have been a better option, but this is the contraption I am working with today. The other thing I'll point out as well, you want to keep the bat parallel to whatever axis you are machining on. So today I am machining in this direction with the Y axis, so I just need to run the spindle back and forth a few times to make sure it is running down the dead center of the bat in order to guarantee that the carve is sitting parallel with the bat itself. So I'm going to do a couple of tests now, make sure this is just running down the dead center and that everything is set up correctly. So after getting everything parallel with the Y axis, it was time to get it ready to start the job. We had the 2 measurements at 270, so we measured halfway down at 135 to get the middle section in the Y axis. We then measured across the distance there to get the center in order to find it for the X axis. So we now have the center point. Before starting, we homed the machine and then navigated it back to this point to reset the 0. Now the reason for this, if anything goes wrong, we can always return to this exact same spot to restart the job. If you want to know how to do this in more detail, there is a link in the corner which will talk you through the full process, just making sure that if anything goes wrong, as I say, you can always restart from exactly the same spot. Unfortunately, I did jam the bit slightly into the wood, so there is a little hole there, but hopefully when it machines it will take that part out. So next thing to do is to start the job. So that is the roughing pass done with the 1/8 bit. It did get very close to the top of the bat, so I just about got away with that one. Sadly, what I didn't get away with was the hole I made earlier. That is right in the center of the S, unfortunately, so I may have to fill that in later and resolve that one way with a little bit of touch-up work. Now the next thing to do is to put the 1mm taper ball nose in. Obviously this is quite a considerably bigger bit than the 1/8 bit, so I'm probably going to jack the spindle up a little bit. But let's get this swapped over, get it reset for the new Z and run the second phase. So we've got the new bit in. It probably is a little bit long for this spindle if I'm perfectly honest, but we're sticking with it and we're going to get the second phase done now. I've reset the Z to the top of the material. The only thing left to do is to start the job, so let's get that going. And there we are. Now, considering I have never done this before, I am really happy with how that's come out. It's looking pretty clean. We've still got to solve that little hole that I made earlier, but other than that, looking very nice. So let's take it out of the clamp, clean it up and take a closer look. So a little bit of sawdust and glue to fill that hole. It can still be seen, but it's better than it was. I then gave it a light sanding down and just finished off by applying a little bit of Danish oil to seal the wood. Now, is it perfect? No, it's really not. And this is 100% user error. Now, the reason I know this is if we take a closer look at some of the inner edges of the E letter, we can see little bulges start to appear. Now, before I even put that large tapered ball nose bit into the spindle, I knew it was a bad idea. And this is what you get. Because of the length of it against that small collet and spindle, there is quite a bit of flex, and it ultimately ends up putting these bulges where there are corners. So yeah, as I say, 100% user error. The good news is the theory was all correct. We definitely made the right decision in taking the text over the edge of the rectangle itself, because this gives a great effect. But if I did it again, I would either use a router with a bigger collet or ultimately a smaller tapered ball nose in it, just to minimize the amount of flex going on. So not perfect, but I'm pretty happy with it for my first attempt at doing a baseball bat. I never should have used a bit that long in that smaller spindle setup. It was a silly mistake that I knew before I even started. But I own up to my mistakes. The outcome is still pretty cool, so it's a win all round. I do hope you found the video useful. If you did, please give it a thumbs up and make sure you subscribe to the channel. Thank you all very much for watching, and final thanks as always goes to my patrons. If you want to get involved for one-to-one help, early access to content and even giveaways, then check out the Patreon links in the description area below. But I will see you all on the next episode.